Hello students, in previous video we have seen enthalpy of reaction, standard enthalpy of reaction, thermochemical equation and guidelines to write thermochemical equation. Today we are going to discuss about standard enthalpy of formation. What is standard enthalpy of formation? Generally, enthalpy of reaction or heat of reaction is determined for one mole of the substance. Here, depending upon types of reactions, there are different types of heats of reactions or enthalpies of reactions. Today we are going to discuss about standard enthalpy of formation. What is definition? Enthalpy change of a reaction. Enthalpy change of a reaction that occurs when one mole of pure compound in its standard state is far from its constituent elements in their standard state. It is called standard enthalpy of formation. What is standard enthalpy of formation? Enthalpy change of a reaction that occurs when one mole of pure compound in its standard physical state is far from its constituent elements in their standard physical states. It is called enthalpy of formation. Now, how it is explained? First point, formation of compound. Takes place from its constituent elements. During solving some problems, we have to write formation equation of a particular compound. For that purpose, its constituent elements are to be known. And it is very easy. If you know formula for the compound, from itself you can know what elements are involved in the formation of that compound. Formation of compound takes place from constituent elements in their standard physical states. Second point, enthalpies of formation of elementary substances. Substances like H2, O2, M2, Cl2, Na, Fe, Cu, phosphorus, sulfur, etc. are always zero. Because these substances are already present in the nature, they are not to be taught, and therefore their enthalpies of formation are zero. And this point is very important during solving the problems. Third, formation of substance, formation of compound or substance involves formation of bonds, between the atoms by liberation of heat. And therefore, enthalpy of formation, of the compound is always negative. That is delta F naught is negative for formation of compound. Now we have to discuss about some problems, some examples of enthalpies of formation. First example, formation of water from constituent elements, formation of 1 mole of water from constituent elements hydrogen and oxygen can be written like this. Formation equation is always to be written for 1 mole on product side from constituent elements. Constituent elements are reactants and compound form is product, and enthalpy of formation of this reaction is minus 286 kilojoule per mole. That means during formation of 1 mole of water, 286 kilojoule heat is liberated by system. Second example, carbon reacts with hydrogen to give CH4 gas. Formation equation for methane gas from constituent elements carbon and hydrogen for 1 mole can be given like this, and enthalpy of formation of methane is minus 74.8 kilojoule per mole. Many examples of enthalpy of formation you can cite. Now we have to discuss about second type of enthalpy. Enthalpy of combustion. Standard enthalpy of combustion. It is denoted as delta CH naught. Combustion means burning of substance in air or oxygen. What is standard enthalpy of combustion? Definition. The standard enthalpy change of a reaction that occurs when 1 mole of the substance in its standard physical state, is completely burned, or combusted. Combusted or oxidized in excess of oxygen, or air. It is called enthalpy of, or called standard enthalpy of combustion. What is standard enthalpy of combustion? The enthalpy change of a reaction that occurs when 1 mole of substance in its standard physical state is burned in excess of oxygen or air. It is called standard enthalpy of combustion. Now, how it is explained? In combustion, substance in its standard state is burned in excess of oxygen. Or air. Again here, standard enthalpies of formation of elementary substances Cu, Fe are 0. Because here one of the elementary substances, oxygen, dioxygen is involved in the combustion reaction, and therefore during solving the problems on enthalpy of combustion, enthalpy of formation of oxygen should be taken as 0 because it is already present in the nature, it is not to be formed. On combustion, organic compounds containing carbon and hydrogen as constituent elements. Constituent elements always form CO2 gas and liquid water. If combustion of carbon or carbon monoxide is brought, they give only carbon dioxide gas. But if organic compound contains carbon and hydrogen as constituent elements, they always produce carbon dioxide gas and liquid water on combustion. But if organic compound contains only carbon, it produces carbon dioxide. Carbon monoxide don't contain hydrogen, therefore on combustion it also produces carbon dioxide. As combustion involves liberation of heat, enthalpy of combustion, enthalpy of combustion is always negative. That is delta SC delta CH naught is always negative. MCQ questions may be asked here. Enthalpy of combustion is delta, always negative. In this way it can be explained. Now some examples you can cite for enthalpy of combustion. First example, when 1 mole of acetylene is oxidized, C2H2 gas, I write rough equation. Being an organic compound, C2H2 on combustion produces carbon dioxide gas and H2O liquid. Now you have to balance this combustion equation from left hand side to right hand side. In acetylene molecule, 2 carbon atoms are there. They produce 2 CO2 molecules. 2 H2, that means 2 hydrogen atoms are there. They produce 1 water molecule. Now reactants are balanced already. Now In product side there are 5 oxygen atoms. That means you have to write 5 by 2 O2. C2H2 gas plus 5 by 2 O2 gas give 2 CO2 gas plus H2O liquid. And enthalpy of combustion, standard enthalpy of combustion of this reaction is minus 1300 kilojoule per mole. This is one example. Now second, combustion equation for 1 mole of methanol CH3OH liquid. I write rough equation. Methanol also produces carbon dioxide gas and liquid water. Now you have to balance this equation from reactants to products. In methanol, only one carbon is there. It produces 1 mole of CO2. 4 hydrogen atoms are there. They produce 2 H2O molecules. Now we have to balance oxygen from product to reactant side. Now there are 4 oxygen atoms on product side. 1 out of 4, 1 oxygen atom is present in methanol. That means you have to balance only 3 oxygen atoms. That means 3 by 2 O2 molecules. This is balance equation for combustion of methanol. And standard enthalpy of combustion of this reaction is minus 726 kilojoule per mole. One more example you can cite. Combustion of carbon. On complete combustion of carbon, it produces CO2 gas. This is balance equation. And enthalpy of combustion. Standard enthalpy of combustion of this reaction is minus 393 kilojoule per mole. In this way, you can cite number of examples for enthalpy of combustion. Here we have seen 2 types of enthalpies of reactions: standard enthalpy of combustion, standard enthalpy of formation. And problems on these reactions can be solved by using the same formula, that is delta RH naught is equal to summation of enthalpy of standard enthalpy of products minus summation of standard enthalpies of reactants. General reaction: A moles of A plus B moles of B to give C moles of C plus D moles of D. In case of this reaction, how enthalpy of the reaction or standard enthalpy of the reaction can be calculated, we have seen it in previous video. The same scheme we will apply to solve problems on standard enthalpy of formation and standard enthalpy of combustion in next video. Thank you.